Greetings everyone. Today we will learn first chapter, units and measurement. Let's begin. Chapter units and measurements. So before starting with units and measurement, I want to start with physics definition and move to branches of physics. Physics. The branch of science that deals with cause and effects of a physical phenomena. So you might be wondering, sir, what is a physical phenomena? My giving you a lecture is a physical phenomena. Birds chirping outside is a physical phenomena. So these are basic physical phenomena. Branches of physics. So first branch, mechanics. First branch mechanics, second being thermodynamics, third being electromagnetism, and what is the fourth branch, students? Optics. Yes, right, optics. And fifth being modern physics. As we move along the course, we will study these branches in detail. So let me start with physical quantity for now. Physical quantity. So you might be wondering, sir, why you didn't explain units and measurement first? So without physical quantity, students, units and measurement cannot be explained. Anything that can be measured physically, is called a physical quantity. So with the help of science, we develop instruments and devices that measure these physical quantities. Okay, students. So this is physical quantity. Now types of physical quantity. Types of physical quantity. Physical quantity. So how many types of physical quantity are there, students? Let me rub it for you first. So types of physical quantity. You would say, so they are basically scalar quantity and vector quantity. Yes, true, but not fully. Vector, and third being numerical quantity. Numerical quantity. So we have heard of scalar and vector only. No numerical quantity in our 9th grade. So this is a new part to our story. So we will see. First, scalar quantity. The quantities that have what, students? That have only magnitude. The quantities that have only magnitude, but no direction. But no direction. But no direction. But no direction. Example, distance, time, speed, work, energy, etc. So you might be wondering, sir, why didn't write only magnitude? It is important to write direction also. We will see why. Vector. Vector quantity. The quantities that have both magnitude and direction. That have both magnitude and direction are called vector quantities. And direction, example, there are many examples: displacement, force, acceleration, many. Let me write. Example, displacement, acceleration, force, torque, etc. Vector is a Greek word, students. That means a carrier. A carrier, what it does, a carrier? It takes you somewhere. So it takes the magnitude to a certain direction. Third, numerical quantity. Numerical quantity. Numerical quantity. The quantities that are a ratio of two similar quantities of two similar quantities and has no units. Okay. So similar quantities being velocity, energy. So this is the thing. Example. There are many examples. So can you name few? Effective index, strain, relative density, etc. I will stop here. In examples. So let me explain one for you. Effective index. Effective index is what, students? So velocity of light in vacuum upon velocity of light in medium. Yes, that is the case. And it is generated by mu c by v, c being velocity of light in vacuum and v being velocity of light in medium. Okay, students. Angle. A certain note here. Angle is an exceptional physical quantity. Numerical quantity is an exceptional numerical physical quantity. Quantity that has both unit and magnitude. It has both unit and magnitude, units and magnitude, unit and magnitude, but no dimension. We will later see how. Now coming to our fundamental quantity and derived quantities. So, but we have discussed our types of quantities. You said there were 3. Yes, but we will see fundamental quantities and derived quantities based on the word dimensions. Fundamental quantity. Fundamental quantities. Fundamental quantities and derived quantities. And derived quantities. So, what is a fundamental quantity, students? Fundamental quantity. Fundamental quantities the quantities that are independent and do not require any other quantity for their definition. Do not require any other quantity for their definition. For their definition. Now you would say, sir, could you explain a little bit? So, suppose mass is a physical quantity and does not require any other quantity for its definition. So, it can exist on its own. Derived quantities. The quantities that are dependent on other quantities for their definition. That are dependent on other quantities for their definition. The quantities for their definition. for their definition. So basic example: speed, relative density also, and many work, power, energy. So these are acceleration. So basically velocity, acceleration, work, power, energy. So these are basic. And you will notice one thing, that all have dimensions. So this is the thing. Fundamental quantities. Fundamental quantities. Fundamental quantities and their units. And their units. And their units. So basically there are 7 physical quantities, fundamental quantities. What are they? First, let me write here, serial number, physical quantity, unit, dimensional symbol. Yes, this will do. Unit. First, mass. Unit, kilogram. Kilogram, kg, m symbol. Okay. So m is not a dimension here, students. It is a symbol. Kg being the unit. Length. And meter. Very good. Meter. L. Third time. Second. Unit. Smallest. T symbol. Fourth, temperature. Temperature, Kelvin, unit, symbol K. So here scientist names start with Lord Kelvin. Electric current, ampere, A symbol. Sixth, luminosity, luminous intensity. Yes, luminous intensity. Its unit is candela. Candela was also a scientist. CD. 7, amount of substance. substance. Yes. Amount of substance. Amount of substance. What is its unit, student? So its unit is mole. Mole. Yes. So these are three scientists. Mole is not a scientist. Now here again a question arises, why mass and amount of substance does not have a difference? Mass is actually the thing that is being measured, and amount of substance is used for particle accelerators and experiments. That way you have to count the particles, number of particles. Sorry. Supplementary and supplementary fundamental quantities. Supplementary fundamental quantities. I should not write here. Supplementary fundamental quantities. First, plane angle. Plane angle is actually anything that is supposed to be in a plane, 2D. Plane angle 2D, and its unit is radian. So you should rub 2D, radian its unit, and dimension symbol RAD. Yes. Second, radian. Solid angle, yes. Solid angle. Solid angle. Solid angle is actually 3D, three-dimensional. So you have a sphere in 3D, and its angle is called a solid angle, radian. Radian. SR being dimensional symbol. Now move to dimensions. Dimensions. Dimensions of a physical quantity. Dimensions of a physical quantity. Dimensions of a physical quantity. the powers of fundamental quantity, the powers of fundamental quantities, fundamental quantities in a physical quantity, in a physical quantity is what, students? Is its dimensions. Yes, is called its dimensions. Its dimensions. So let me explain one for you. Density. Example, density. Density. Mass upon volume m L cube. L cube being length into breadth into height. This makes m1 L minus 3. Note, according to our definition, the powers 1 and minus 3 are dimensions of physical quantity. The dimensions, the powers of 1 and minus 3, powers 1 and minus 3 of m and L in density are dimensions of density, are dimensions of density respectively. Yes. Yes, thank you. Now, let's see numericals. Numericals. Yes, sir, we were waiting for it. Numericals. What are the dimensions of gravitational constant? What are the dimensions of gravitational constant G? Okay. So, solution. According to Newton's gravitational law, What it is, students? F is equal to GMM upon R square. Certainly every student likes it. R square. Now what are force dimensions? So you would tell us. So let's start. F is equal to MA. MA. M L T minus 2 . Yes. So this makes M1 L1 T minus 2. This is acceleration part. This is acceleration. This being mass. Now comparing first and second, we get comparing first and second, we get F is equal to yes, F is equal to MA G M R square. Okay, both being force. Now, what was the dimension of force, students? So, M1 L1 T minus 2, and this makes G dimension as G M into M upon L square, sir. Okay, this makes G dimension is M minus 1 L cube T minus 2. Yes, this is the dimension of gravitational constant. Okay, students. Now moving to next question. What is the next question? What is the dimension of angle? What are the dimensions of angle? Dimensions of plane angle theta. Okay, students. Plane angle formula. Yes, tell me plane angle formula. Very easy, sir. Arc upon radius. Yes, very good. So this makes the dimension. Oh, sir, it is dimensionless. You told us. Yes. So arc arc dimension is L, radius dimension being L, so theta dimension becomes M0, L0, T0. Yes. So it is a dimensionless quantity, but its unit is radian, as we have discussed. So theta, plane angle, dimensionless quantity, dimensionless quantity, less quantity. I don't think double L will come right now. Dimensionless quantity, dimensionless quantity. Dimensionless quantity, unit radian. Yes. Now next part, next question. Now our system, I will discuss a system of units. System of units. There are many system of units. Many system of units. System of units, but we mainly use in our life, we use MKS and CGS. While international units is MKS. MKS is what? So meter, kilogram, second. Yes, true. Meter, kilogram, second. Second, CGS. What is CGS, students? So centimeter. Let me write first. Centimeter, gram, second. Yes, that is also true. Now, our last question of today. Our last question of today is convert 1 joule to ergs. to ergs. Let's see, 1 joule is equal to how much beta? MKS units. MKS unit 1 joule. 1 ergs, let me actually, is what? CGS unit. CGS unit. So let convert 1 joule upon 1 ergs. So mass into velocity, half mv square, mass into velocity square, m L square t minus 2. This is the formula for this. Same goes here. Now convert. Kilogram, 1 kg into length square, 1 meter square. That 2 is squared. 1 meter is squared. 1 meter square, second square. Second minus 2. Right? Now 1 gram this makes 1 centimeter square, 1 second minus 2. Now convert 1000 gram makes 1 kg and 1 meter makes 100 centimeter. Now I will square it. This I would not write. This is being divided completely. This makes 1 gram 1 centimeter. This becomes 1000 gram cancelled, in centimeter gets cancelled, and this becomes 10 raised to the power 4, and 1 joule is equal to 10 raised to the power 7 ergs. Yes. 10 raised to the power 3. So this becomes 10 raised to the power 7 joule. I will stop here. Thank you.